Hello grade 9s and welcome to the first of 2 exam practice videos in which we will be factorizing algebraic expressions. But what makes these problems special is that we will be required to use a variety of techniques in order to factorize the expressions as far as possible. Now, just a quick reminder of all of the techniques that you have learned about so far. Firstly, you know that you always start off by identifying a highest common factor, if there is one. Sometimes you may first need to change a sign by using the sign change rule, after which you may then be able to remove a highest common factor. You should also be familiar with dots, which is short for the difference of two squares. And lastly, you should be able to identify trinomials and factorize trinomials using the different methods that I've taught you in the previous videos. Now, there are 3 problems displayed to your screen. I would like you to try these problems before you work through them with me. So go ahead and pause the video and work through these problems. Press play as soon as you've completed them. I hope that you enjoyed working through those problems on your own. Let's now work through them together. Question A requires us to factorize negative 2x squared plus 16x minus 30. We always start off by looking for a highest common factor. So let's look at the coefficients and the constant. Is there a highest common factor amongst these numbers? Yes, there is. Each of these numbers is divisible by 2. Now you may see that the first and second term contain x, but the third term is a constant. Therefore, x is not common and is not part of the highest common factor. So we can now write down the highest common factor, and notice that I wrote down negative 2. Now let me explain that to you. Can you see that the original expression consists of 3 terms? If you think further, you may remember that 3 terms indicate the presence of a trinomial. 3 terms are a trinomial. So what we want to do is we want to get the coefficient on the x squared to be positive 1. If we only factorized out a positive 2, then we would have a negative on that x squared, and we don't want that. So we're going to factorize out that negative 2. We now take the first term and divide it by the highest common factor, and we are left with x squared. We take the second term, positive 16x, and we divide that by negative 2. A positive divided by a negative is a negative, so we get negative 8x. Now we take the last term and divide it by negative 2. Negative 30, please don't forget the negative, divided by negative 2 gives us a positive 15. Now we are done taking out the highest common factor. We question, is there now a difference of 2 squares? Do we have 2 terms and only 2 terms that are separated by a negative, and are both of these terms square numbers? No, we don't have any of that. So we can skip difference of 2 squares and we can move on to trinomials. Do we have a trinomial? Yes, we definitely do, contained in the brackets. So perhaps we can factorize that trinomial by making use of the techniques that you have learned about so far. So we start off by writing the negative 2. Please do not forget that negative 2 because it is one of the factors that we have factorized out of the original expression. Now, to factorize a trinomial, we start off by writing out 2 sets of brackets. If you take a look at the first term in that trinomial, it's x squared. What we multiply together to get x squared? Well, we multiply x and x. So the first term in each set of brackets is x. Now we need to decide on which signs to place inside of the brackets. So we take a look at the sign on the last term, the constant in our trinomial. Can you see that we have a positive sign? That positive tells us that the signs contained in the brackets will either both be negative or they will both be positive. They're going to be the same sign. Now the question is, will they both be negative or both be positive? Well, to decide on that, we take a look at the second term, that middle term in the expression, negative 8x. The sign on that term is negative. Therefore, both of the signs are negative. We write a negative in each set of brackets. Now comes the tricky part, where we need to look for factors of 15, which of course when we multiply together will give us positive 15. But when added together, they should give us the coefficient on the second term, which is negative 8. So let's think, which numbers can we multiply together to get 15? Well, we can multiply 1 by 15, and we can multiply 3 and 5. That will give us 15. Now, I'm going to place negatives on all of these factors. The reason I do so is because we have chosen negative signs in our brackets. So I'm giving each of these factors a negative because they will be negative inside of those brackets. Now we're going to add our sets of factors together to see which set will give us the negative 8, which is on the second term inside or in that trinomial. So we say negative 1 plus negative 15, and that gives us negative 16. That's definitely not going to work because negative 16 is not equal to negative 8. Let's try the other set of factors. Negative 3 minus 5, that gives us a negative 8. So that means that that is the set of factors that we're going to use. So we place a 3 and a 5 in our sets of brackets. The order here does not matter because both of the brackets contain a negative sign. At this point, we are done factorizing our trinomial. It's very important that we don't just stop here. We need to go back to the highest common factor, difference of two squares, trinomials, to see if we can identify any of those again. But there are none of these, and we can't factorize any further, which means that we have completed this problem and factorized completely. Question B requires us to factorize 4y squared minus 16. And as always, we always start by looking for a highest common factor. We have a constant of 4, a coefficient of 4, and a constant of negative 16. Both of these numbers are divisible by 4, so at least we have a number as part of our highest common factor. Now the first term contains a y, but the second term does not contain a y. Therefore, we know that y will not be part of the highest common factor. So we start off by writing down the highest common factor, which is 4, because 4 and 16 are both divisible by 4. That is the highest common factor. Now we take the terms in the expression and divide them by the highest common factor, starting off with the first term, which is 4y squared. 4y squared divided by 4 leaves us with y squared. We then go on to the second term, which is negative 16. Please do not forget the negative. Negative 16 divided by positive 4 is negative 4. That negative sign is very, very important. At this point, we have taken out the highest common factor, and we can move along that list to the difference of two squares. Now, when you look at the expression contained in the brackets, do you see a difference of two squares? The correct answer is yes. Firstly, we have two terms that are separated by a negative sign. The first term is y squared, which we simply obtain by putting a square on y, or by saying y times y. So y squared is a perfect square. The second term is 4, and 4 we can obtain by saying 2 squared. So 4 is also a perfect square. We therefore have a difference of two squares, and we can factorize that expression in the brackets using the method we've learned about the difference of two squares. We start off by writing out the 4. Please do not forget the 4. And then to factorize the difference of 2 squares, we write out 2 sets of brackets. Now, in the first bracket and the second bracket, we will have different signs, one a positive, one a negative. The order does not matter. To obtain y squared, we say y times y. So therefore, the first term in each set of brackets will be y. To obtain 4, we say 2 times 2. So the second term in each set of brackets will be 2. At this point, we have factorized the difference of 2 squares, and the question is, do we have a trinomial? Of course, the answer is no. We go through that list again, starting off with the highest common factor, because we need to factorize as far as possible. Highest common factor, difference of 2 squares, trinomial. We can't factorize any further, and we have therefore factorized as far as possible and completed this problem. We're now on question C, the last problem in this video, and we need to factorize the expression that you can see displayed to your screen. As always, grade 9s, we start off by looking for a highest common factor. Now, if you look at that pretty complex expression, you'll notice that there is a 9 and a negative 15. 9 and 15 are both divisible by 3. They have 3 as their highest common factor. So already we have the idea that there definitely is a highest common factor. Now, if you look at the sets of brackets, you'll notice that in both the first and second set of brackets, there's an x. If you look at the first set and the second set of brackets, you'll notice that in both sets, there is a y. So at this point, you may be tempted to try and use the sign change rule in order to factorize out a highest common factor. But in this case, we actually do not need to use the sign change rule because there's no need to change the signs of the terms inside of the brackets. So let's start off by writing out the first term, 9n, and what's contained in the brackets, x plus y. For the second set, we're going to write negative 15. And then all that we're going to do is we're going to use the commutative law of addition, and we're going to swap the terms inside of the second set of brackets around. So the x stays positive x, the y stays positive y. At this point, you should notice that without changing any signs, we have made our brackets look exactly the same. So there was no need to use the sign change rule. Now, since that set of brackets is the same, we can factorize out that set of brackets. Notice that I wrote it at the end, the set of brackets that we're factorizing out, and what I always refer to as the leftovers, which is the 9n and the minus 15, I wrote in the first set of brackets. The order truly does not matter. You could have written x plus y in the first set of brackets and the 9n minus 15 in the second set of brackets. But you will see in a moment the reason why I've written it in this order. We have taken out a highest common factor. But if you look at the leftovers, right, what we obtain by dividing the first term by x plus y and the second term by x plus y, you will notice that we have a 9 and a 15 still. And both 9 and 15 have a highest common factor. There's also an n in the first term in that set of brackets, but there's no n in the second term, and therefore n is not common. So we can factorize out the highest common factor of 9 and 15, which is 3. When we factorize it out, we take the first term, 9n, and we divide it by 3. That leaves us with 3n. We then take the second term, negative 15, and we divide that by 3. That leaves us with negative 5. Grade 9s, please do not forget your signs. A negative divided by a positive is a negative. We must not leave that last set of brackets. We must write it down. So we now write down x plus y in the second set of brackets. And at this point, if you move through the list, you will see we do not have a difference of two squares, we do not have any trinomials, and we do not have any more highest common factors to factorize out. So at this point, we have factorized as far as possible. Now, grade 9s, it is actually not necessary to complete the first and second set. If you notice from the word go that 9 and negative 15 are divided by 3, and that x plus y is a common set of brackets, then you could go straight from that original expression to the final answer and you'll obtain all of your marks. At this point, we have factorized as far as possible, and grade 9s, we have come to the end of this video. I hope that you've enjoyed this video. Please remember to watch the second exam practice video, in which we will be going through more of these expressions that we will be required to factorize. Thank you so much for joining me.